Hello, this is section 10.4 hypothesis test for the population standard deviation. So we had the hypothesis test for the population proportion, population mean, and then this is the population standard deviation. So chi-square distribution that we're going to use right now. So which is this is how you can get the chi-square with the degree of freedom. So characteristic for the chi-square for the review from chapter 9, it is not symmetry as you notice here in the picture, right? In the picture. And then the shape of the chi-square distribution depends on the degree of the freedom, just as a student T distribution. As the number of the degrees of the freedom increases, so which is like a 30 here, and the chi-square distribution becomes more nearly symmetry, which is that they talk about this graph. And then 4, the value of the chi-square is non-negative, greater than always, and then greater than or equal to 0. And then testing a hypothesis about the population variance and standard deviation. So to test the hypothesis about the population variance and standard deviation, we can use also following step. So the step is a sample is obtained using simple random sampling from the randomized experiment, and the population must be the normally distributed. Step 1. Determine the null and alternative hypothesis. The hypothesis can be struck in one of the three ways, so which is a two-tail, left tail, right tail. Null hypothesis all becomes the same with the sigma, and then the alternative is not equal to for two-tail, less than for the left tail, and then the gray for the right tail. And then step 2, we need to select the level of the significance, which is alpha, to avoid the type 1 error. And then we also need to compute the test statistic with these formulas, and then we can get a classical approach. We use the table A to determine the critical value using the n minus degree of freedom. So with the two-tail, which is gonna be the whatever the critical value falls in the critical region, and that means that we reject the null hypothesis. Left tail is on the left as a critical region, right tail is on the right. And then also step 4, to compare the critical value with the test statistics. So once you have a critical values, and then we compare this, and then if that's the case, and then we reject the null hypothesis. Left tail, we care about this. Right tail, we care about this. Okay, so the p-value approach, yeah, we are using those, and then the use a table A to approximate the p-value for the left or right tail test to determine the area under the chi-square distribution with the n minus 1 degree of the freedom to the left for the left tail test, the right for the right tail test of the test statistics. For two-tail test, it's recommended the technology be used to find the p-value, obtain the confidence interval. That's actually the make it better. Okay, so this is a graph of the pictures of the two-tail, left tail, right tail. So this is a critical region, and also I have only two left tail. What's going on here? Hold on a second. I think I made a mistake. I didn't know that. So I have to change that into the two tail. Sorry about that. This means we have to have these places and also these places. Okay, so which is t sub 0 is actually here too. Okay, so we have to find this both. Okay, here to check that out. And then technology use, yeah, of course. And then we have to use a p-value is less than, oh, sorry, what am I doing? Okay, and p-value less than alpha to compare rejected null hypothesis and state the conclusion. Caution, the procedures in these sections are not robust, and therefore if the analysis of the data indicates that the variable does not come from a population that is normally distributed, the procedures presented in these sections are not valid. Okay, so let's look at the problem. All right, so I'm going to put out the two approaches. Okay, so to do that. Okay, so In order to do this, okay, so problem says a can of the 7-Up states that the contents of the can are 355 milliliter. Quality control engineer is worried that the filling machine is miscalibrated. In other words, that she wants to make sure the machine is not under or overfilling the cans. So she randomly selected 9 cans of 7-Ups and measured the contents, and she obtained the following data. So, wow. So the number doesn't come out the same, right? So 351, 360, so far. Okay. All right. So this time we have a standard deviation 3.2 and then alpha is 0.05. All right. So let's start it. So step 1. H of 0, we are using the sigma standard deviation equal to 3.2. And then we have to find the alternative hypothesis, a sigma. So let's say this time this is miscalibrated. And then she thinks that it's gonna be the greater than, right? So, okay, so I put the greater than 3.2. So step 2. The alpha is 0.05, which is the level of the significance. So step 3, which is a sample standard deviation. So using those data to find the S, isn't it? So if you use the formula, so sample standard deviation come out at 3.464 because we need it. And then we can find the test statistic, which is T sub. Oh, so what am I doing here? I'm in the different place, right? Okay, so it's going to be the chi-square sub 0, which is n minus 1 s square over sigma sub square, which is you have 9 minus 1, which is there's a 9, 7 up, they check. S is 3.464 square over sigma is 3.2 square. Then I compute the 3.464. So that's what I got. Oh, sorry. What am I doing? I'm copying the wrong answers, okay? So this becomes 9.374. So step 4, we do the classical approach. So in order to get, so this is a right tail. Okay, let me write down the step 4. So step 4 is a right tail because it's a greater. And then we determine the critical value at the alpha equal to 0.05 level of the significance with the degree of freedom of n minus 1, which is 8. Degree of freedom. And then, so which is if you use the table, the chi-square of the 0.05, which is alpha, which becomes 15.507. So this is a test statistic. So if I use a normal curve, and then I see there's a y, so t sub 0, which is it's going to be 15.507. So this is actually the critical region. But when I put that as a chi-square sub 0, which is right here, which is a 9.374, which does not fall in the critical region. So in the step 5. And then because of that, we just say that we fail to reject the null hypothesis. So this is okay. All the can is okay. All right, p-value approach. We do as a step 4. So this is actually the right tail. So p-value is the area under the chi-square distribution with the degree of freedom of 8 because 9 minus 1 is 8. And then we got the test statistic as a 9.374 as a p-value which is you get that from the P of chi-square greater 9.374. Okay, and then so if you check the table, the p-value which come out as between the is about the 0.10. Okay, so now the step 5, we compare to the p-value should be less than alpha, p-value 0.10, and then the alpha is 0.05, which is not true. Okay, so that's why we fail to reject the null hypothesis. So step 6, which is we keep the null hypothesis, which is there is insufficient evidence at alpha equal to 0.05 level of significance to conclude that the standard deviation of the can content of 7-Up is greater than 3.2 milliliter as a standard deviation. Alrighty? Okay, so if I just showing the one example in here, but if you have more question to ask from your homework or any, let me know. Thank you for listening.